So file management is another aspect that is important from OS perspective. And in this particular topic, will be more focus on logical organizations of file management and physical organizations of files. So what are files? Files are the central element to most applications. And we know that file because whenever you want to save data permanently, we put in some kind of file. It can be of any type, image file, video, audio file. It can be text file, binary files, executables, object files. Different types of files are there. So whenever we want to store any data permanently, first we create file for that and then we store it. And what are the desirable properties for any file? Of course, long-term existence, permanent storage kind of stuff, shareable between processes. A simple example, if you want to share a particular data which is stored in particular file between different processes, you can do that with the help of files. And there must be some structure for that file. These are some desirable properties for any file. And if we talk about file management system, it consists, basically file management system, what it is, ultimately it is a part of OS and it's a software. So it consists of utility programs that run as privileged applications. So there are a number of things which are covered under this umbrella called file management system. Number of things need to be done by file management system, and ultimately they are some utility programs. And again, they are running as part of kernel. That is why it is called run as privileged applications. And mostly it is concerned with secondary storage because files, they are stored on secondary storage. The typical operations that can be performed on any file, they are very simple functions. You can create file, delete file, you can open and close file, and you can read, write. These are the typical operations. And there are few terms that you need to be aware of, though you must be aware of it. I assume that field, record, file, and database. Now, if you have gone through this DBMS subject, this terms it should appear familiar to you. Fields are nothing but basic element of data. Okay, any one value when you store it is called a field. It contains a single value and it is characterized by its length and data type. Okay, sorry. Fine. So we were discussing this terms field. It is a basic element of data. It contains a single value and characterized by its length and data type. And then records is nothing but collection of fields in particular order. We all know this because basically if you think about DBMS system, one particular row of your table, it represent one record. So similarly, not necessarily that we are discussing this file fields and records in terms of DBMS only. In general, these are the terms. And file is nothing but, again, it has some name and it is a collection of similar records, and it is treated as a single entity, and it may implement access control mechanism. Now access control mechanism means who can use this file. Again, the usage of this file contains, at least if we talk about Unix and Linux system, there are three aspects of usage: whether you can read or not, whether you can write or not, whether you can execute or not, if it is executable file. So at least these three aspects are there of the access control mechanism. So whenever you want to provide access mechanism, whenever you want to implement access control mechanism, then at least you need to say that, you need to provide that whether this file can be read by this type of user or not, write by this user or not, or it can be executed by this user or not. Then once you have files, sometimes you have multiple files which are related to each other, and that collection is called database. So these are some terms which are related to this file management. Now, what is objective for a file management system? What you want to achieve with file management system? So first, meet the data management needs of the user. How you can manage all the data. Okay. Guarantee that the data in the file are valid. Optimize the performance. What kind of performance? Reading, writing the file, accessing the file. Provide IO support for variety of storage device types. Normally we use secondary storage, that is our hard disk. But sometimes you are using USB drive, there you can store files. Sometimes, earlier days people were using tape drives, which are different kind of storage device, though we are not using it right now, but it was there. So for different type of storage devices, it should provide proper IO support. That is the job of file management system. Okay, again, if I just want to give you an example of any file system, and you are quite aware of that. In Windows, you are using NTFS, right? That is one type of file management system. In Linux, it is ext3 now, ext2, ext3. These are the different file systems. In Mac, it may be different thing. So ultimately, if you remember, whenever you need to install OS, you do this. And again, if you want to use USB, okay, sometimes you need to, when you format it and when you create file system there also. So that is, I mean, not in all type of USB it is required. In some type of USB you need to do that. Sometimes you need to do that when you format it, right? So basically, file management system objectives, these are some objectives for that file management system, and one of them is provide IO support for variety of storage device types. Provide a standardized set of IO interface routines to user processes. How user process, your process, can access any file. So this is, these interfaces, when we call interfaces, by programming perspective, if you see, it is nothing but functions like read, write functions and all those functions. But these are the library functions. Internally, these library functions need to be supported by your file management system. That is IO interface routines. Provide IO support for multiple users if required. Minimize lost or destroyed data. So these are some of the objectives for any file management system. And what are the other requirements for any general purpose system? So each user should be able to create, delete, read, write, modify files. Each user may have controlled access to other users' file. Each user may control what type of accesses are allowed to the user's files, especially in Linux and Unix. If you have done that, I'm not sure, I don't know whether you have done this chmod command, chown command. Have you tried this command, chmod, chown, in your lab? Because they are related to file access control. Okay, so you know that how you can provide the different rights, whether a particular user can read or not, whether a particular user can write or not, right? Executable or not, I mean, someone can execute or not. So that can be controlled. So each user may control what type of accesses are allowed to the user's files, and each user should be able to restructure the user's files in appropriate form. Whenever you want, you can restructure your file. Few more requirements. Each user should be able to move data between files. You can copy data from one file to other files. Each user should be able to backup and recover the user's file in case of damage. And each user should be able to access the user's files by using symbolic names. Again, this comes, I mean, there are links, they are called symbolic links, which are software links that you can do with Linux system also. So if you have run those commands, okay, then you must be aware of this kind of stuff. I mean, this are the operations that you should be able to do as a user. Whenever you work with file, these are some of the operations, general purpose. I mean, they are very general requirements for any file management system, and you should be able to do all this stuff. And in a very brief view, if we see file system architecture, the layering structure. So at the bottom level, you have directly disk device driver or tab device. So based on your device, if you are using hard disk, it is disk device driver. If you are using tape device, which are not, you know, currently we don't use tape drives, but in earlier days people were using tape drives. So that kind of driver is required. So depending on your disk, depending on your device, you require driver for that. Nowadays, whenever you install any operating system, by default these drivers are they get installed on your system, so you need not to do that. So it is part of OS, these drivers. Above this driver there is basic file system, and what it contains. Basic file system is what kind of operations is performed, we'll see next to this. Above that you have basic IO supervisor. Above that you have logical IO, and then above that you have some logical file access methods or logical file structuring. So we will be discussing this part in little detail, and we'll see what other layers contain. So device drivers, you all are aware what is device driver. For any kind of device, IO device, you require special software called driver, which can directly interact with that device. So it is at the lowest level. It communicates directly with peripheral devices, and it is responsible for starting IO operations on a device. It is directly communicating with the device, and it processes the completion of an IO request. So whatever IO request is generated, it will complete that. Above that you have basic file system. So it contains few basic operations of the file management system. What kind of operations it performs? This basic file system layer is also known as physical IO. Now you need to understand there is two things, logical IO and physical IO. If you see this diagram, this is logical IO and this is physical IO. Now what is that? Because logically when you look at the file, it is nothing but a collection of records. If you go back to this term, it is nothing but collection of similar records. So when you see file as logical entity, you see it as a collection of records. So when you do logical IO, you work with records. I want this particular record, something like that. But physically, these records, how they are stored. Okay, so that is physical IO. It is primary interface with the environment outside the computer system, and it deals with exchanging blocks of data. Now, if we just narrow down our discussion only to hard disk right now, forget about other type of devices. Let us focus only on hard disk, which is our secondary storage device. And this hard disk, as you know, we divide this hard disk data in terms of blocks. The chunk of data that we transfer between hard disk and main memory, it is called block. So deals with exchanging blocks of data. So this basic file system, what it does, whenever it works with secondary storage, that is our disk, it exchanges the blocks of data. It is concerned with the placement of blocks. It needs to decide where this block will be put in the secondary storage, at which sector, which track, it will decide that. It is also concerned with buffering blocks in main memory. If you remember disk cache, that is what we discussed in last lecture, disk cache. It is nothing but some of the secondary storage blocks that you keep in your main memory, that is called disk, cache, or buffer. So this basic file system, it is also concerned with that. Above that, you have basic IO supervisor. So this is responsible for all IO initiation and termination. So whenever you say I want to read file, whenever you say I want to write file, whenever you say I want to create file or something like that, this IO supervisor will create IO request for you. And it control structures deal with whatever control structures are associated with this. What they do, they are dealing with device IO, scheduling of that request. I hope you remember our disk request, IO request that we discuss different policies for this, or completion of this request, like policies like what we the scan policy, cscan, optimal, scan, cscan, FIFO, look, clook, and step scan, fscan, sstf, shortest seek time first. These are the policies that we discussed. So scheduling, it is part of that. File status. So this basic IO supervisor, the main job of this layer is to start your request and complete that request. I mean, to do whatever it need to be done at the end of the completion of the request. So basically it selects and schedules IO with the device. So scheduling of your request, mainly it is done by this layer. Above that, you have now logical IO. So it is interface between programs, logical command, and physical details of disk. So when you say I want to read, that is your command. So this logical IO is an interface between programs, logical command, and physical details of disk. So physical IO deals with blocks, while logical IO deals with records. That is what I told you. Basic file system, it is physical IO. It deals with blocks, and logical IO deals with records. And it enables users and applications to access records. So it will convert your actual physical data, physical blocks, into required records. I mean, it is converting that format and give it to you. It maintains basic data about file. Basic data about file means who has created and all those stuff. And above all this, you have access methods. All these are called access method. How you access file logically. Because as a programmer, how you see the file, that is logical organization. So this is logical organization of the file. And after that, we will also discuss physical organization of the file. Logical organization of the file means when you look at the file on your screen, how it is organized, in what form. So there are different logical organization of the files. And we are going to discuss this. But actually how these files are stored on hard disk, because ultimately on hard disk, your file is stored in forms of blocks. So how they are stored on hard disk, that is physical organization. That is another part of this discussion. So access method, basically how you access the file, how your files are logically organized. So it's the closest to the user. Definitely it is the next layer from your program point of view. It reflects different file structures. Provides a standard interface between applications and the file system and devices that hold the data. And access method varies depending on the ways to access and process data for the device. So ultimately, that is what we are going to discuss after this. This is an overall diagram. If you see here, these are called elements of file management. This is your programs or commands that you give. And maybe in that command, you say what operation you want to provide on which file. That is your input. Now it takes help of directory management and user access control mechanism. Based on this, it will work on some logical file structure. This logical file structure, then it is going to be decided what access method is there. And then file manipulation functions are performed on that. Okay, based on access control. some file manipulation functions are performed. And to perform that file manipulation functions, maybe you want to write something. So what kind of access method you are using? Accordingly, it will be written. And it will see this files in form of records. This is logical IO. Because now it looks at this file in form of collection of records, and it will find out particular record, and there it will write something. Then this records, and there is a block. This is logical organization of your file. This is physical organization of your file. So basically these records, they are divided. I mean, now the whole file, it is divided in form of blocks. And this is right now buffer, disk cache. These blocks are there in your disk cache. So that is called blocking. Record to block and block to record. This conversion, it is called blocking. And finally, this cache blocks, they are transferred to the actual hard disk. And again, they are always in form of blocks also. So you can see that this, up to this point, it is file management concerns. A special file management module that you have. This stuff, these functions are done by file management system that you have, like NTFS or whatever you have. And after that, from here, this is some overlap. There is some overlap at this point, logical IO point. From here to here, it is completely part of OS. OS handles that because device driver, it is part of your OS. Device driver, it is part of your OS. Of course, file management system, they are also considered as part of OS, but it's a special module and it deals with this part. So what are there? Directory management is part of file management. See, directory management is there. So basically it load file from directory to perform any operation. Access control, verify user access rights. Then access method, it translates user commands to file manipulation commands. Blocking, IO is performed on block by block basis. Scheduling, needed for optimum performance, and free space management. Now we come to this point, file organization. And currently we'll be discussing logical file organization. So file management, referring to the logical structure of records. It refers to the logical records structure of the record. So file management module, it works with logical organization. And physical organization we'll be discussing later. So it will be determine the way in which files are accessed. This logical structure of your file, it is determined by the way in which files are accessed, access methods. So what are some of the criteria to organize these files? What are the criteria based on which you decide, okay, I will organize this file in this particular way? So some of the important criteria includes short access time. You want to make your access time very short. You should be able to access particular record quickly. Ease of update. You should be able to update your file easily. Economy of storage. You want to optimize the storage. Simple maintenance, so that your maintenance becomes simple and your records are stored reliably. So these are some of the important criteria based on which you decide, okay, what should be the structure of my file. Now priority will differ. Out of all this criteria, priority can be different, and it depends on the use. Okay, whether you are using CD drive or you are using hard drives, depending on the device also, it differs. So these are the logical file organization types. These are the file types which are file organization types which are discussed in this chapter. Pile, sequential, index sequential, index, and direct or hash file. So what is file organization? It is nothing but just as you get data, put it in the file. That's it. There is no actual structure. It is the simplest form of organization. Data are collected in the order they arrive. In whichever order data are coming, you put it in the file. That's it. There is no structure actually. Okay. And what is the purpose? Purpose is to accumulate a mass of data and save it. As data comes, put it in the file. There is no structuring required. Just append the data. Variable length records, you can see different records are stored in your file and they are of variable length. Even number of fields which are there inside every record, they can be of variable number. Different records may have different number of fields. Even the order of these fields may be different. So there is no structure, in fact, no structure at all. Now, if you want to access any record from this file, definitely it is very exhaustive, because you need to search each and every record until you get your record, or you reach to the last record and you say that now there is no such record. So when you need to search from this kind of file, it is definitely going to be exhaustive search, and it is time consuming. Then comes sequential file. It is very similar to our table kind of stuff that we use in DBMS. There is a very well structured data. Every record has same number of fields in the same order, and it is most common format. Fixed format used for records with fixed length. All fields are same. Field names and lengths are attributes of the file. Now, here sometimes you need to also mention that in each record, what is the field name, because you don't have fixed format. So you need to say this is the field name and this is the value. One example that I can give you, when you store some JavaScript objects, different JavaScript objects in one file, because each JavaScript object, it is nothing but name value pair. Similar to that, you can consider this file. But then sequential file, every field is fixed. Okay, this is the field. Let's say this is the serial number, this is the ID number, this is the name, this is the city, or something like that. So every field is decided, and type of field is also decided. So you just need to store value for that record, and you need not to worry about what is the field name, what is the type, what is the size. You need not to worry, and that is automatically becomes the field names and length. They become attributes of the file. You need not to worry about how you can store this value. You just need to store the value of that field. That's it. And in this kind of file organization, but key fields are used. We use key fields so that every record can be uniquely identified. And these records are stored in key sequence. Whenever you store these records, you maintain the key sequence. If it is just a serial number is your key sequence, suppose serial number is your sequence, it is your key. So whenever you store any record, you store it in the sequence of that key values. Further in this sequential file. But this works poorly when queries are made for individual records. Suppose you have lakhs of records and they are stored in some sequential order of the key value. Now you are supposed to search any particular record. Okay, how will you search it? I want to search particular record with the key value, let's say 2000. I cannot directly access that, right? This is not an array where I can say file of 2000, give me that record. No, it is not possible. You need to start searching from here and go to the 2000 value, and then you can access that record. So it works poorly when queries are made for individual records. For very large sequential file, that is a problem, because you need to search so many records before you reach to your required record. Insertion and additions, they are also difficult, because new records are placed in a separate file called log file. Now see, normally when you want to insert new record in this kind of file, you do not directly put that record here. There is one extra file which is used, extra space, which is called log file. You put your record there in log file, and time to time, that log file and this actual file, they are combined, they are merged, and they are merged in a way that this order is maintained. The sequence of the key based on key value, that should be maintained. And why they do it this way? Because if you put one record if you want to put your record directly inside this main file, and every time you need to make sure that I will put my record in the main file according to the order, so many shifts you need to perform. It will take so much time. So better that you put all the new records in some other file, again in that order, in particular order, and whenever after some period, you just merge those two files, and that is called log file. You merge that log file and the main file and make sure that all the records are in the order. So that is why it is also time consuming part. So what can be the solution for this problem? You can also use linked list. So in that case, you need not to worry about shifting the things here. Let's say this is the record number 201 and this is record number 220. Now I want to add 210. So of course I need to add that record in between these two. But if I want to add record in between these two, of course all these records need to be shifted and everything. So that is time consuming. But instead of that, if I use linked list, it is very simple. I can add that record here. I just need to change the pointer. So that is one possibility. Then there is another type of file called index sequential file. This is this kind of file normally we use in database systems, in our tables, index files, index sequential files rather. Okay, your records are in sequential form, again same as this. It is similar to this. All keys are there in particular sequence. Now the only thing is we generate index on that. And I hope you know what is index. Have you gone through this subject called DBMS? Have you gone through this idea of indexing? Okay, so you must be aware of that. So what we do, we can create index, either single level index or you can have multiple level index also. This shows multiple level index. Highest level index is the smallest and lowest level index is having the maximum number of records. So this index basically, it is just the storing. For example, one example I am giving you. Let's say I am using single level indexing. My main file contains, let's say 1 million records. That is 10 raised to 6. 1 million is 10 raised to 6. Okay. Now what I can do? All these 1 million records, they are stored in particular order of the key. Key 1, key 2, key 3. In that order it is stored. Now what I do? I create one separate table called index table. And what it does, it contains every 1000 key here. Key number 1, key number 1001, key number 2001, something like that. And from their key, it is pointing it to the proper record. So this will point to the record number 1. This will point to the 1001 record. This will point to the 2001 record. Okay. So just tell me, if I maintain only single level indexing here, I have 1 million records and I store key values and its pointer for every 1000 records. How many records or how many entries will be there in this index file? Can you tell me how many records will be there, entries will be there in this index file? If I store pointer to the every 1000 record here, every 1000 record pointer I store here, how many entries will be there? These are 10 raised to 6 entries, 10 raised to 6 entries, and I store pointer for every 1000 record, that is 10 raised to 3. So 10 raised to 6 divided by 10 raised to 3, that is 10 raised to 3. So this index file or this table, it contains 1000 entries. So now if I want to search 5555, if that is the key record, that is the key of the record that I'm searching, I will just go through linear search of this index. I'll come to the record number 5001. Then wherever it is pointing, I will go there. And from there, I will start sequential search, linear search. So 5001, 5002, 5003, and then accordingly, I will reach to the 5555. So now my search is reduced to less number of search. I hope you are getting the idea of index sequential file. And similar to that log file that we have in sequential file, if you want to add new record, you do not directly add that new record in main file. Rather, you maintain another file which is called overflow file. New record you put here, but then there is a special field after every record, which is a pointer in the overflow file. Suppose you want to add record with the key value 5900. And already you have here one record 5899. So from that record, there is a pointer to that record, new record in the overflow file, because that is a sequence. That is a sequence. Here you have 5900 record. Here you have 5899. From there you point here. And this is how you provide this overflow file, you maintain this, and periodically this overflow file, it is merged with this main file, so that all the records are in particular sequence. So there is index file and overflow file, two extra things. Apart from your main file, now there are two things, index file and overflow file. Index file is a simple sequential file where each record contains two fields, key and pointer to the main file. So here it is a key 1001, key number 1, which is pointing to the first record of the actual file. Key number 1001, which is pointing to the 1001 record. So that is key and pointer. And overflow file, it is similar to log file, but it is integrated. Give me a minute. So overflow file, it is again similar to the log file, where we put new data, which is going to be merged with main file periodically. So addition operation, how it is performed? New record is added to the overflow file. Record in the main file that precedes new record is updated to contain a pointer to the new record. That is exactly what I discussed. Suppose you are adding new record with key value 5900. Now you will search the main file and find out the record which is going to precede your new record. It can be 5899, but if such record does not exist, it can be 5850, because you don't have any record between 5850 and 5900. You don't have any other records. So which is the preceding record? That is 5850. So from there you provide a pointer to this new record. And if the preceding record is in the overflow file itself, then its pointer is updated. Suppose it is also possible that you are adding 5900, but just before that you might have added 5899, which is actually preceding record, and it is also in the overflow file. So you need to update the overflow file pointer from that record to new record. What is the advantage of index sequential file? It reduces the access time, definitely, because now you are using index only. Sometimes you're using multi-level index, which will further reduce your time, but then you require more storage for that. I hope again, if you have learned B plus trees, that is used for this indexing purpose. B plus trees data structure. Are you aware of B plus tree data structures? So that is used for this indexing purpose. Advantage is reduced access time can be improved further by using multiple level of indexing. And issues, when the file is searched using a criteria other than the key, this approach won't work, because index are generated only on key fields. If you are searching record by any other field and not by the key field, then this approach is not going to work. Then again, you will be, you will be come down to the approach sequential search. Then similar to that index sequential file, now we have index file, which is not required. It is not required that your file is in a sequential form. Your file can store data in any form, but there is index for one or more than one fields. Now you create index for one field of your record or multiple fields of your records. And then there is a pointer only from, and again, there are two types of index files, exhaustive index and partial index. Exhaustive index means whatever records you have in your file, for every record you have index, and you can have multiple index on multiple fields. Sometimes you have only partial request, a partial index, because some of the records you want very quickly. So you generate index only for those records and not for all the records. And then there is a direct or hashed file. Now, what is this direct or hashed files? Now you don't save index, but what you do for particular key value of your file, for your record key, you find out one, you provide one hash function. You use one hash function, provide that key to that hash function, which will generate some value. and that value is actually pointing to the record in the file. So now you have direct access. So for an example, I want to search particular record with particular key value. I apply hash function on that. Whatever value it will give me, I just point it to, there is a pointer to that record, and I will use that pointer. So there is a hash table which contains all these records, hash values, and from there you simply point to that. That is direct hash file. Direct or hashed file. Then comes directory management actually. Okay. So this about what we just discussed, that was the logical organization. What we discuss here, there is a different types of access methods or logical organization of the files. Pile, sequential file, index sequential file, index file, and direct hash file. But these are some of them. There can be some other structures also, but these are the structures which are discussed in your book. So we have discussed it. Now we will be moving forward to directory part. So what directory contains? It contains information about files. Okay. We are right now looking at the contents of the directory. So what it contains information about your files that are there in the directory. What kind of information? File attributes like access control attributes, some other attributes like when it was created, what was the last access time, what is the size. These are the file attributes. Location, where this file is stored, actually in the hard disk or something like that. And ownership, who is the owner of this file. Some such kind of information are stored for every file inside directory. Directory itself is a file owned by the operating system and provides mapping between the file names and the file itself. So there is a mapping between actual file name between file names and actual file on the storage. So what kind of basic informations are there in the directory regarding file? File name is there, basically name as chosen by the creator, whatever file name you have given while creating it, and it must be unique within a specific directory. We all know this, right? File type, what kind of file it is, maybe text file, executable file, or something like that. File organization, for systems that support different organizations. If your system supports multiple organizations, then only this information is required, otherwise not. Volume, basically address related information. Especially you must be aware of this drives concept in your Windows C drive, D drive. That is ultimately volume. So it also indicates on which volume this file is stored. Starting address on the hard disk, which block, what is the size of that file, that is current size of the file in bytes, words, or blocks, in whichever form you want. And size allocated. We will see that file allocation. After this, we will look at the file allocation. There are two aspects. When you create a file, how much space should be provided for that file? It should be a fixed space. It should be variable space. So we will be discussing those aspects. But when your file is created, some space is provided, some size is fixed. So how much size is allocated, and out of that, how much size is used? Okay, that is the current size of the file. Let's say you have created a file and OS has given you 4 kilobyte, but out of that you have used only 2 kilobyte. So size uses 2 kilobyte, size allocated is 4 kilobyte. Then access control information, which are stored in directory elements. Ownership, who is the owner. Access information, it may include the user's name and password for each authorized user. Permitted actions, what you can do with this file. Can you read, write, execute? Can you transmit it over network? Can you share? This permission access are there. Some users information regarding that file, that is also stored in directory. All this information, we will see that all this type of informations are stored in a directory. So what kind of users information are stored in directory regarding the file? When this file was created, who created that file, identity of the creator, date, last read access, when it was last access, who read that file lastly, when it was last modified, who did that, when it was last backup, what is the current usage, whether it is currently locked or not. Okay, and again, these are very general information. OS to OS, it may vary little bit. OS to OS, this information may vary little bit. So this is about directories. Then we will be looking at something called record blocking. Okay, record blocking. Now, what is that record blocking? If you see here, logically your file is records, but physically it is block. So there is some conversion. How these records are stored on blocks, how these blocks will provide records, specific records. Because normally records are small in size, blocks are big in size, normally. So it is possible that one block contains multiple records. How they contain these records? Okay. How you put records within particular block. So that is what we are going to see. That is called record blocking. So records are the logical unit of access of a structured file, but blocks are the unit for IO with secondary storage. And we know that record is logical unit, block is the physical unit. Records must be organized as blocks to perform IO operation. These records must be organized within blocks, or they must be stored within blocks to perform IO operation. And there are three common approaches: fixed length blocking, variable length span blocking, and variable length unspanned blocking. Now, what is that? Whether we should use fixed length or variable length. So when it comes to block size, okay, it should be fixed length or variable length. But definitely fixed length simplifies IO and organization, because you know what is the size of each block. So definitely it is going to simplify your job. So one factor, deciding factor regarding block size, that is whether it should be regarding block, whether it should be fixed length block or it should be variable length. But in general, fixed length blocks, they are easy to deal with. Then what should be the size of the block? That is another deciding factor. Before we understand how these records and blocks interact, we need to also discuss this design issues, whether we should use fixed block size or variable blocks length. But again, there is some common observation that fixed length simplifies IO and organization. Size of block, whether you should use large block or small block. Again, this large and small are very subjective matter. But in general, large size, it will result in more records passed in one IO operation, because actual IO operation, physical IO operation, actually it is performed in terms of blocks. If you have a large size block, you can have more records within one block. So while doing one block transfer, you can perform more IO, more records you can transfer, because your block is of big size. And it is good for sequential access, where you use this principle of locality. If you know that currently user is trying to work with this record, but in near future it is going to work with the other records after that. So it is very good if you have large block, because then you are doing in single IO, you are transferring all the required records. If you use small size block, then it will be useful in absence of locality of reference. If locality of reference is not there and there is a random access to the records, then small size is very useful, because then your time for transferring the block will be reduced. Now we discuss these three things: fixed blocking, variable length, and variable length unspanned blocking. So in fixed length, records are used. Okay, can I show it here? Yeah. In fixed blocking, fixed length records are used. Record size is fixed. It is similar to paging. An integral number of records are stored in a block. So now, what it says, that record size are fixed. You cannot have variable size of records. All record size are fixed. Okay, and that you are going to put in your block, and you can put only integer number of records. You cannot put let's 1.5 records. No, you can put 1 record, 2 record, 3 records, if they can be contained within the particular block. So you can see that this is fixed blocking. This is one track and this is second track. And let's say your file contains total 8 blocks. Your file is having 8 records. Okay. and you want to put it in hard disk. So this is one block. Okay, this is second block. On track 1 there are 2 blocks, on track 2 let's say there are 2 blocks, suppose something like that. And one block contains 2 records. Here one block contains 2 records. So every block contains 2 records. Then there is some extra space. This gray area, okay, it is the gap due to hardware design. So we have nothing to do with that. It is because of hardware design that these are always space gap between 2 blocks. But then you can see this area, which is kind of fragmentation, or because block size is only up to this. This is the block size. And you are trying to fit 2 blocks, but still there is some space left because block size is also variable. You can decide what should be your block size. You have decided my block size is, let's say, 512 kilobytes. So it is possible that the track has some extra space where you cannot keep one more block because it's a very small area, small space left. So it is a waste due to block fit to track size, due to the whatever fixed size of block you have decided, but still there is some free space and it cannot be utilized further. So that is a waste of the space. And this particular space, it is waste due to block size constraint from fixed record size, because you have decided that my record size is fixed and still block size is up to this, but within this point you cannot add one more record because it is not enough. So this is another kind of, so these are typical internal fragmentation. Basically these are like internal fragmentation. But this is fixed blocking, where your inside your block you put only fixed size records, and that is also in integer number. You cannot put 2.3 2.5 2.6, no, fixed numbers of records you can put there. That is fixed blocking. Then you have variable length span blocking. Now you can have variable length records also. So it is like this. This is one block, and you can see there is no internal fragmentation here, only hardware gap and some extra space wasted because of track size, which is not matching with the block size. But now if you can see that all records are of different, can be of different size, and you can also store one portion of record here and remaining portion of the record you can store on the another block. That is also possible. Thus the only thing that you require this kind of pointer here, that remaining part of this block, this record, is stored on another block. So that is required. That's it. Otherwise you can also do this. You can store portion of your R6 record here and remaining portion you can store on another block, another track. That is also possible. Just pointer is required. So you can see there is no internal fragmentation here. This is variable block spanning. Span means your record can span multiple blocks. Your record can be stored on multiple blocks. That is called span, variable blocking span. Variable length span blocking. Then you have variable length unspanned blocking, where you cannot span your records among multiple blocks. So you cannot do that. Okay, remaining part of R4 you store here, for some portion you store here, and then you store. No, it is not allowed. You can store full records only. Of course, record size can be variable. The length of the record can be variable, but it cannot span to multiple blocks. So in that case, again, internal fragmentation is there. In that case, internal fragmentation is there. Okay. But in different cases, different strategies are used. So what is the summary of this record blocking? Fixed blocking is common for sequential files with fixed length record. It is more useful in that case. Variable length span blocking is efficient for storage, which does not limit record size, but it is difficult to implement. And then variable length unspanned blocking, it results in wasted space and limits record size to size of blocks. So every approach has its own advantage and disadvantage in different scenarios. Okay, then secondary storage management is the next topic, which I think I'll do that in next lecture. Yeah, fine. So remaining part I'll complete in the next lecture, that is on the Friday. And if you have any question, you can ask.